So today's topic is going to be data modeling, but I guess we are running a little late, but that's okay. So the question that I ask you is: we have so far seen some, silly data models, and they are written in such a way to make some queries possible. But the question that we want to ask is: is this a good data model? Okay. So this is the one that we had for the quiz, and then we also have the one that is on the website as an example database. And so basically we are going to think what makes something a good database model and what makes it a bad one. Now there are many different ways to look at it. So first we will see it mathematically. Mathematically we are going to define rules and say that you must have this. But the math is not enough, because it will not give you the full view of what's the good data model. Then we are going to approach it a little differently with ER diagrams. So, I know that this is not something you necessarily think about, but are there things here that you can notice as being bad? Like, why would you design it that way? It kind of revealed itself when we were writing the queries anyway. Yes. Doesn't have the area, okay? I do have the area for the episode, but somebody asked me that question: what if there were no guest heroes, right? The area, why would I store it there? Yeah.
Getting the hero name for the show that I guess appearance happened in is kind of like so if you're trying to find the hero name for the TV show that I guess appearance happened in.
You mean like the real name of the hero?
Yeah.
Yeah.
Like going backwards is kind of weird.
Right. So how would you find the real name of the hero, right? So then you have to find it. So you cannot even find the real name of the hero unless it was actually in a TV show, right? Kind of weird. What else? Yes. Right. You can only have one guest appearance. It's like only really boring or low budget shows. Okay. And that can only be friend or foe. Yes. What else? So most of those we will not be able to do with normalization, but these are good things to keep in mind. So here's an interesting one that is not maybe obvious to you, but is kind of important, right? So the real name of a hero, does it generally change? Right? Superman is always Kent, right? But I actually have the story for every single show that Superman has been in, right? So this is actually a problem because that information is not really relevant to the show. Generally, that doesn't change, right? So this is a problem, but in many different ways. So let me show you the other problem a little better by this example. Suppose you have this database of music groups. I don't actually care about Beatles, but I put it in there. I'm a Queen fan. So I read this thing on Facebook that Ringo Starr took the quiz, which Beatles are you? And he came out as John Lennon. So that shows you how good those quizzes are. All right, so this table, this is all we have. Okay, you have a music group, you have an artist, genre, they founded and they joined. Okay, so now what genre is Queen? Opera, right? But I stored it 4 times for emphasis. Should I really do that? Okay, so this is the same thing that would happen with the hero name and real name, right? Because if you have multiple shows, you're going to repeat that information. The problem is that once you repeat that information, then if you decide that in fact the new categorization of pop rock is for Queen invented, cool pop rock, then you have to change it in all four. If you change it in one, it's not clear which genre it belongs to, right? Okay. So what happens if I delete all the artists for Queen? Okay. So I basically decided I made a mistake. I removed all four artists from my database. So I want to say that these four artists are not in this music group. But what will happen is that when I remove those four tuples, I will also lose all information about Queen, right? Because all these things that it's a pop rock group has nothing to do with who is in it. I know you can find, objections to that. All right, let's move on. So one problem is that you are repeating information. The second information, you are coupling things that don't actually necessarily belong together. Suppose that you realize that, in the future you have music groups with no people in them, those machines are taking over, and they are forming music groups, and so, but you cannot store that information because I made a design decision. That's the way it's supposed to be, right? So your data model is kind of coupling things that really are not necessarily, have to be together, and that results in you repeating information. In fact, very often what happens is that you get information piece by piece. You may get information about the music group, and then you basically later find out who's in it, then you can add it, right? But in this data model, you cannot do that. So you sometimes deal with like student information system and that there's weird dependencies, and you get annoyed, but you cannot register until you are in this database, and until you're in that database, you cannot, or that you cannot see the classes, but you cannot see the classes anyway. So the point is that you have to decide what is the right set of things that depend on each other. And this is not something that is going to come to you. It's not like an observable phenomenon that these are the rules. You are going to define the rules. You are the database designer, and you're going to define the rules about this database and these attributes, depending on how you understand what these attributes mean. So now we're going to do all of this without even yet caring about what the key is. But let's think about what would be the key for this relation. So remember, a key is a set of attributes such that no two tuples can have the same values for the key. Can the music group be a key? Okay. Can the artist be a key? Do artists ever join multiple music groups? So then artists cannot be a key, right? Okay. So what would be a key then? Artist plus? Plus base join. I'm okay with that. What else? Artist plus group is okay. Unless the person can, leave and join. But I'm okay with that too. Yes?
Yeah, I was just saying
Right. So what if the artists on the same year can join multiple groups? So they cannot decide which one succeeds, right? So, but we are going to basically make some simplifying assumptions. We are not going to think about all possible combinations. But let's assume that the artist can only be in a music group only once. Okay, we're just going to make it simpler. Because real life is too complex to actually store in a database. So let's say that that's the case. In that case, artist and group can be a key, right? Do you agree with me? Okay. Let me ask you a slightly different question. Okay. Of these attributes here, the genre relates to which attributes? So genre is about music group, not about the artist, right? Okay. I mean, I understand if you're like, if there are music majors here, and this is like, like a different era of the user, of the artist, and so they're going to be simpler and, like, boring. Okay. How about date founded and date joined? What do they relate to? Just the artist? Artist plus music group, right? So, given an artist plus the music group, there is a date that they joined it, and there's a date they may or may not have left it. How about date founded? Is that about the group or the artist? Group. What if I have date of birth? That will be about? All right, so this is what we are going to write. There's going to be a lot of math and lots of definitions, but this is what we are doing. Okay? So, we are going to define this as a logical statement. And we are going to define what's called a functional dependency. Okay? So all that we are saying is formalizing what we just said. So a functional dependency, or very often I'm going to just use F and D so that I don't have to write functional dependency. Okay? And a functional dependency for a relation is a rule that we define based on the meaning of the attributes. Okay? We decide what are the rules. And it's basically a statement of the form like this, where these are attributes in a relation. Okay. So think of A1 through AM as a set of attributes, B1 through BM as a set of attributes. They may or may not be disjoint, it's not important. Okay. And all that it says is that, so, it says that if A1 through AN implies B1 through BM is true for R, then if two tuples have the same values for the left side, then they must have the same values for the right side. Okay? And if you understand this definition and memorize it, everything we do is derivable from this. Okay? I got into computer science, so I don't have to remember anything. So this is the only thing you really have to learn. Everything derives from this. Okay? Let's try to see what I mean with an example, with the same example that we were looking at. If two tuples have the same value for same value for group name, then they must have the same value for genre and they font, right? So that's what we are seeing here. If they have the same group name, then these two should be the same. If two couples have the same group name and artist, then they must have the same date join, right? I mean, we don't have two clean Freddie Mercury, but if there were, then they must have the same date join. In fact, so I may have other information, but these two should imply this. So that's what we are trying to write. we're going to go a long way before we can tell why that data model is bad officially, but we know that it is bad. But if I wanted to explain the dependencies that are in that relation, I know that group name implies genre and date founded, and that, for example, artist name may imply date of birth. I thought that I had a date of birth at some point, but date of birth is about the artist, but the date joined is about the artist and the group together. So remember that these are not observable, these are things you say should be true about your data. And then you basically describe what your data is based on this. Okay? But these kind of make sense to us for the most part. But for somebody who's designing a more sophisticated database, they may not make sense. They may have a slightly different one. That's okay. The point is that given your table, you have to tell me what your rules are. Then I can tell you if you have a good table or a bad table. And at some point, you're going to start to feel it in your bones, like bad. Change it. So that will be, in a week, you have to get there. So let's do a few other examples. So where is this one? Let's go back to this one. Okay. So for example, what are some functional dependencies for TV shows? Right, hero name implies real name. Show name alone or show name with channel? Because is it possible to have the same? So okay, so let's write that down. So it's a good question. Okay, so let's see. Suppose I wrote this. Show name implies ended. Okay. So is it possible to have two tuples with the same show name, but different ended or not ended relations, right? Has there ever been two TV shows with the same name? Right? So you can say yes or no, right? But that's what the functional dependency will tell you, right? If you say, I'm going to allow in my database two Superman shows, but in different channels, right? Which is not necessarily a great model, because what if there are two Superman on the same channel, right, at different times? But if we don't allow that, then we should actually use show name and channel implies ended. Anything else? Episode ID implies area? Okay. But is episode ID alone or episode ID with show name and channel? Because different shows may have channel 1, right? Right? So think about it. If you saw two episode 1s, it is okay for them to be for different shows. But if they are for the same show, then they have to have the same show, right? So in fact, you can say that show name and channel implies hero name. Is it the case that, so we also said show name channel and episode ID implies area. So show name, channel, episode ID, does it also imply guest hero and friend info? According to this model, yes, but eventually we are going to say it's not a great model. But according to this model, that in fact they also imply guest hero and friend info. Okay. And how about show name and channel? Do they also imply hero, the real name of the hero? So if you see the same show name and channel, will it always have the same hero real name? Right, now think about this, okay? Now this is why we're going to come up with some rules. So if you did have, let's say, Supergirl on CBS, this is nice that I chose the one that I don't actually know the real name of. So this is the name of the show, this is the channel, right? So if you had two separate ones, then we know that the hero name is going to be Supergirl. Because it's the same show, right? If that is the case, the real name is also going to be Kara something. Okay? So there are lots of rules you can come up with, but some rules are the core rules, some rules are derived from them, right? But the point is that there are many rules you can say that obviously if show name and channel says that that's the same hero name, then it should also be the same real name because of this one. Okay? So let's try a couple of others. Let's try student. So we have Rin, first name, last name, major, year, email. Okay. Let's just put a SSN here for order. Okay. So what can you tell me about students? You should know something. Yes? Yep. Given the Rin person, Rin name, Rin ID, I should be able to find out everything else because it uniquely identifies a person. What else?
First name,
Right, it's possible. In fact, somebody told me that somewhere in IPI is called this. Yes.
Email will give you first name and last name.
So can two people have the same email? No. Do emails ever get recycled? I don't think so. So it's actually, given the emails, you can tell all the rest, right? Why can't you get RIN number? Well, RIN is private. If you have two students with the same email, should they always have the same RIN number? This is actually an interesting point. What if a student graduates and comes back, and I don't know if they get the same RIN, but yes. Right, Social Security number should imply everything, right? If you have the same social security number stored for a student, it should imply. So, in fact, now there are some caveats. I'm going to talk about that in a second. Okay. So the idea is that in your database, are you ever going to store two tuples for the same student with the same email but two different rings? That makes no sense, right? That would be very confusing. Or are you ever going to store in your database two students with the same SSN but different rings? Yes? Oh yeah, why? But in that case, your old tuple will actually be deleted. So like in the student database, you're not going to have two different tuples. Ken is actually quite bad about just removing it from the database as soon as you kind of like open the door. So the point is that in fact that is true, but you are not going to store two different things. The point is that it would be confusing to have two people with the same SSN but different rings. Okay? So what I'm trying to get here is that there are many different functional dependencies that may hold, and some of them may be more important than the others. But what we really would like to do is, given these, we want to now talk about a few things. The first thing we would like to be able to say is what is the key for a relation, given the functional dependencies that you do have. Two, we would like to say, given the keys that you have, is this a good model or not? And then we're going to have to really learn a little bit more about what that means. Okay? And three, if you have a bad model, what are some ways to make it good? Okay, so these are the three things we are going to talk about. Now, so one thing that we have to first do is take these functional dependencies and understand what that means. So given a set of functional dependencies, you may have some that are unnecessary, some that may be derived from the others, and some that are totally useless. So we would like to get rid of all of them, so that when I look at what is a key, I only use the functional dependencies that I need. Then we're going to go further. So I'm going to stop here and then pick up from this point. But next class, we are going to go a little faster, so I'm going a little late.